Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of identifying proportional and non-proportional functions with the standard 8.5H in the great state of Texas, and we are using item number 12 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to identify a proportional relationship. So let's define that. What does that mean? Well, a proportional relationship means two things. We have a constant rate of change, and it varies directly. And so when we say it varies directly, that means we could represent it like this. We can say y over x. If we look at the relationship between the two variables y over x, you could represent it with a constant, k. So this is something we worked on in 7th grade. And when we have y over x equaling k, and that's it, that's how we could represent the relationship. What that means is that it includes the origin. So these are our major points here for what a proportional relationship means. Constant rate, right? It's that y over x equals k. You can also say it varies directly. Those two mean the same thing. And it includes the origin. And so that means it has on its graph there 0, 0. All right, so let's look at these four situations. I've got two verbal descriptions and I've got two tables of values. We're going to look for that constant rate, constant change, and including the origin. So a key on a map indicates that 1/2 inch represents 12 miles. Well, I'm going to make a little table of values here because I want to get it into a unit rate here. So if I've got 1/2 inch, that's going to make 12. I want to get a unit rate. So if y over x, I want to get that x to be 1. So let's double it. I'm going to go like this. Okay, so every 1 inch makes 24 miles. Therefore, 1/2 an inch makes 12 miles. Well, how could I represent this if I were to, double this again, right? I would get 48. It looks like I'm just going to keep making that 24. So it looks like I do have that constant rate of change, right? We could say y equals 24x, or we can say our constant rate of change, right, is going to equal 24 over 1, which is just 24. So this looks like it actually is a proportional relationship because if I had 0 inches, that would be 0 miles. If you haven't gone anywhere on a map, then you haven't gone anywhere for that representation in real life. All right, so this looks good. Let's double check to make sure B, C, and D are incorrect. So we've got a coupon here that represents 228 each for apple juice. Okay, so I'm going to write it like this. Y equals, my rate is 228. So far, so good. Reduces the total cost by $1. There we go. That's our problem. When we have this y-intercept right here, that means we're in slope-intercept form. And when we have a slope-intercept form like this, that means it's non-proportional because it doesn't go through the origin. Our y-intercept is -1. So this is not proportional. This is non-proportional because it doesn't go through the origin. All right, so if we're looking at here, we need to find differences here. So let's find our m, right? Change in y over change in x. So this is going to be, what is that, 850? 8.5 over 2, so that's 4.25. All right, which is what this is. Okay, looks good. And then when we get this right here, between 3 and 5, we get 950 over 2. 4.75. So the difference between 2225 and then 1275 are different, so that's non-proportional. This also has the same problem. This is 3 over 3, and this is 3 over 4 if you look at the changes there. So that doesn't work. Our answer is A.